Yes, sir.
Good morning, students. Today, I'd just like to continue with where we had left off last class. So, module 2, just one more topic is left out, which is velocity potential and stream function. If we complete this topic, we'll be completing the second module. Okay, so sufficient portions has been covered, so it should not be a problem. Before I start the topic on stream function and velocity potential, I would just like to brush up the last class and then I'll come to this point. On the study material for deriving the continuity equation, please go through the derivation of the 3D continuity equation in Cartesian coordinates. Okay, polar and cylindrical coordinates not required. I have given you only one. Please go through that one. Okay. Then second one, I have sent you some problems. Have you seen? I have sent you some problems yesterday on Laplace and continuity equation. In the 4th semester WhatsApp group also I have sent. And some material I have sent to your Google Classroom. Have you seen? Can you see here? All of you getting
Yes,
it?
sir.
Problems
Yes,
on continuity equation? Yeah. Please see those problems and get back to me if you have not understood. Okay? Next class we will discuss if you have not understood. Problems on continuity equation and Laplace equation. Okay? I think some 3-4 sheets are there. Please go through that. Okay? Jen, all of you can hear me?
Yes, sir.
Okay. Then this is regarding the portions what we have covered so far. Next, in the Google Classroom, I have given one assignment. Have you seen? Google Classroom, I have given one assignment.
Yes, sir. Yes, sir.
And due date is 9th April. Is there any problem in accessing the assignment? Yes?
No problem, sir.
No problem. So what you can do, in case after doing the assignment, you are not able to post it in the Google Classroom, there is some problem or anything, keep it with you only. Submit to me when the college reopens. Okay? It should not be a problem. Okay?
Yes, sir.
Is it clear?
Yes, sir.
Yes, sir.
Okay. So all of you have assignment. The due date is 9th April. I have given you 1 week's time to complete the assignment. Some 3-4 questions are there. Okay, in the assignment, please complete the assignment and submit in the Google Classroom. If you find any difficulty, let us see, you can submit to me in the college if there is any problem. Okay, now this is what I wanted to say. Now, is there any doubt for any one of you? I have also posted some problems on velocity and acceleration, how to calculate the velocity of fluid flow and also the acceleration. How to calculate the acceleration. Yesterday I discussed AX, AY, AZ and all that. So I have given you the problems also. Please go through the following things. I will repeat again. You can note down if you want. Continuity equation to be derived. You have to practice that one. Second one, problems on velocity and acceleration. Third one is the assignment. These 3 things you have to remember. These 3 things are very important. And in the second module, what all I have given are the frequently asked questions in the main exam. Is it clear? Okay. So, after brushing up all these things, I would just like to start with the new topic. Okay. If you have your smartphones next to you, please open. Today I have sent some study material at 10 o'clock. Please open the study material of the 4th semester group, WhatsApp group. Please open the study material so that you can understand what I am saying. Okay? Yes, Vagmesh. Yeah. Okay. So now the topic is stream function and velocity potential. I will start with this now. Now stream function, as I told you, why it is important? Stream function is a mathematical representation of a streamline. Okay, so what is a streamline? We spoke, isn't it, that day? Streamline, streak line, and path line. Streamline is the path, the flow of the fluid. Okay, a mathematical representation of a streamline is called as a stream function. Okay, now the stream function is represented by the symbol psi, not phi, psi, the Greek letter psi. Now, if you have opened the fourth semester group, what study material I have said, please open that so that you can follow me. It is easy to understand. Have you opened the fourth semester group? Study material?
Yes, sir.
So,
Okay. So, today, 10 o'clock I have sent, please open that one. Okay. Now, in the page 1, you see stream function is there, correct?
Yes, sir.
Yeah. So, stream function. So, what is a stream function? Stream function is a mathematical representation of a streamline. How do you represent a streamline? By a stream function. Now, if u and v are the velocity components, I told you there are 3 velocity components, u, v, and w. U is the velocity component in the x direction, v is the velocity component in the y direction, and w is the velocity component in the z direction. Now, here it is a 2-dimension flow, only u and v components, velocity components are there. If u and v are the velocity components, then u is equal to del psi by del y, del psi, it is not phi, del psi, 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 del psi by del y, Greek letter, and v is equal to minus of del psi by del x. Then this psi is called as the stream function. Stream function is called psi. Okay. Similarly, velocity potential. What is the use of the velocity potential? It is used for analytical investigation of the velocity fields. See, what we are talking now is all mathematics. That means differentiation and integration only. Why we have to do that? Mathematical study of fluid flow is stream function and velocity potential. So when we do the velocity analysis, analytical investigation, I can know the velocity. I can know what is the streamline, how the path of the fluid is there, how it is, and all those things we can calculate mathematically. That is why we are using stream function and velocity potential. Velocity potential is used for analytical investigation of the velocity fields. Now, here u, velocity, is equal to del phi by del x. It is phi, not psi. Phi by del x. And v is equal to del phi by del y, where phi is called the velocity potential. Okay. So, stream function we will discuss, velocity potential we will discuss. Then what is the relationship between stream function and velocity potential? Del phi by del x is equal to del psi by del y, and del phi by del y is equal to minus del psi by del x. Now, please, if you open the study material what I have given in the 4th semester group, it's very, very easy for you to understand because you can be following me as I keep reading. Okay. Now, this is all you have about the stream function and velocity potential. That is theoretical aspect. That means what? What is stream function? What is velocity potential? Where it is used? What is the relationship between stream function and velocity potential? Okay, this is the theoretical aspect of that. Now, coming to the problems. In the main exam, there will be one problem on stream function and velocity potential, definitely, guaranteed. Okay. Now, I will read out the problem. Please open the study material from your smartphones and see that. The velocity potential in a 2D flow field for an incompressible fluid is given by phi is equal to x into 2y minus 1. Determine the velocity at the point x equal to 3 and y is equal to 4. Determine the stream function psi at that point. Now you should know that all the fluid flow they will give in the form of equation. Why they are giving the form of equation? Because they are all stream functions or velocity potentials, and they will be moving in the x and y direction. mathematically the fluid flow is represented by an equation. Okay. So in the equation, phi is equal to x into 2y minus 1 is given. So what is this phi? It's nothing but the velocity potential. Okay. So come to page 2. Please open the page 2 now. Are you understanding? All of you are getting? Jayan, Milan?
Yes, sir.
Okay.
Yes, sir.
Now, in page 2, the problem, we'll start the problem. Given phi is equal to, what is the given equation? Phi is equal to x into 2y minus 1. Okay. So we have to find component of velocity in the x and y direction. U is equal to velocity, U is equal to del phi by del x. So del by del x of phi. Substitute for phi. What is the value of phi? X into 2y minus 1. Correct? Phi is x into 2y minus 1. So substitute for phi. So what is the differential of x into 2y minus 1 with respect to x? So x will go up. It is 2y minus 1 differentiating. Similarly, v is equal to del phi by del y. That is del by del y of x into 2y minus 1. That means I have to differentiate phi, that is 2x into 2y minus 1, with respect to y. With respect to y. So if I differentiate with respect to y, then what is remaining? 2 into x. That's all, 2x. Therefore, u is equal to 2y minus 1 and v is equal to 2x. Now, I have calculated the velocity u and v, which are the velocities in the x and the y direction. U and v I calculated. Now, he is asking, what is the resultant velocity at the point x comma y, which is nothing but at the point 3 comma 4. At the point 3 comma 4, I have to find the resultant velocity. The resultant velocity capital V is equal to root of u square plus v square, small u plus small v square. That is equal to, what is u square now? U is 2y minus 1. So 2y minus 1 whole square plus, what is v? 2x. So it is 2x square. So substitute x equal to 3, y is equal to 4 in the equation. Then you will get root of 2 into 4 minus 1 whole square plus 2 into 3 whole square. So the resultant velocity capital V is equal to 9.22 meter per second. Okay. He has asked what is the resultant velocity. If you want to calculate resultant velocity capital V, you should know u and v. Now to know u and v, you know that u is equal to del phi by del x and v is equal to del phi by del y. Substitute for phi, which is given in the equation, you can find the resultant velocity. Now, any doubts in this? Milan, Jayant, anybody? Chinmay?
No, sir.
Charishma, Ibad? Yeah.
No, sir.
Understood,
No
all
doubt,
of you? No doubt? Yeah, it's very clear.
Yes,
Okay.
sir.
Okay. Now, this first portion is over. Second, now I want to know what is the stream function, what is the velocity potential. So, how to do that one? We know that u is equal to, now I'm talking about the stream function psi. U is equal to del psi by del y. Okay. Now, u is equal to 2y minus 1. Okay. Now, how did I get u is equal to del psi by del y? Because stream function is said to be del psi by del y. That's equal to u. And del psi by del x is equal to minus of v. Okay. So del psi by del y is equal to u. It will be equal to what? 2y minus 1. Same thing, whatever is there for u. 2y minus 1. Similarly, del psi by del x is equal to minus of v. What is the value of v? 2x. So minus v will become minus 2x. Okay. Now, I know the value of del psi by del y and del psi by del x. Both I know. Let us call it equation 1 and let us call it equation 2. Now, what I want to know, I want to integrate the whole thing and find the value of stream function psi. Now, because this psi is a differential, if I have to know the stream function psi for the whole fluid flow, then I have to integrate, correct? I told you that day only in the class, if we have small bits of any element, if we integrate, we will get the value of for the whole mass. Whereas if we differentiate, we are bringing down or splitting up components into smaller components, the big one into small components. Now here, del psi by del x is a small element. I want to zoom it and make it into psi. I want the value of psi. So what I should do? I should integrate the value of this del psi by del x. So integrate with respect to what? With respect to y. So integral of del psi cross multiply will be equal to integral of 2y minus 1. Take dy this side into dy. Any doubt in this? Jayant, Milan?
No, sir.
Okay. So when I integrate this, what is the integral of del psi? It is psi is equal to integral of 2y minus 1 into dy will give what? Y square minus y plus k into x. Now what is this k into x? Constant of integration, isn't it? When you integrate, you add a constant c or k, you add a constant of integration, and it is depending on the value of x. So k into x. So we'll call that as equation 3. Okay. Now I got this equation, but it is in the form of equation. I don't know the value of psi. If I should know the value of psi, I should know the value of k of x first, that constant value. So what I will do, differentiate equation 3, this above equation what I got. If I differentiate, I will get del psi, differentiate with respect to x, del psi by del x is equal to del of k by del of x. Y component will be 0. It won't be there only. So substitute the value of 2 in equation 4 for x. So I will get minus 2x. Del psi by del x is equal to minus 2x. That is equal to del k by del x. Once I get that, I will get what is k? K is equal to cross multiply minus of integral of 2x into del x. So that is I'm cross multiplying, which is, and if I integrate, I will get is equal to minus x square. So this equation 3 becomes, now I'll substitute for the value of k. Therefore, psi is equal to y square minus y minus, what is the value of k? X square minus x square. So what is the stream function at the point 3, 4? 3 is the value of x, 4 is the value of y. Yeah, substitute this in the value of equation 3. Once you substitute in the equation 3, yes, please don't talk in between. So stream function at 3, 4 is substitute for x and y. Y is equal to 4, x is equal to 3. So you'll get 4 square minus 4 minus 3 square. It is equal to 3 units. We say units. Stream function and velocity potential is in terms of units. Okay. Any doubt in this problem? Any doubts?
No, sir.
Then, is it clear? Now, I sent the material to you. It's very clear now. I think you can do this. One problem will come definitely for the main exam. See, I am focusing on the main exam first. Important problems which are likely to come. The next step is the internal test. Okay. So I want you to be prepared for the main exam itself. Okay. Similar way, there is one more problem, that is problem number 2. I'll just finish that problem number 2 and that will complete your module 2. And I will just do this problem number 2. The velocity potential for a 2D flow is given by, okay, well, what is the velocity potential? Phi. So it will be given in terms of an equation. Phi is equal to c into x plus y square. determine the corresponding stream function. What will be the velocity of flow at the point 2, 1 in the flow field? This is the problem. Now, sir, given that phi is equal to c into x square plus y square. Now, we'll do it the same way as we did the last problem. Differentiate with respect to y. What I will get? Del phi by del x. It is equal to 2 into cx. Now, u is equal to del phi by del x is equal to 2cx. Let us call it equation 1. Then, what is v? Del psi by del y. So, if you differentiate, what I will get? 2cy. Similarly, u is equal to, this is for the velocity potential. For the stream function, u is equal to del psi by del y. That is equal to 2cx, equation 3. And v is equal to minus del psi by del x is equal to minus 2y. So I got 4 equations. Equation 1 and 2 will describe the velocity potential, u and v. Equation 3 and 4 will describe the stream function for the velocity u and v. Is it clear? Any doubts in this, please? It's very, very important. You have to understand this concept. Okay. Now, what I will do, I will integrate equation 3 with respect to y. So I will get psi is equal to 2cxy plus f of x. Whether you write k of x or f of x or anything, it is a constant which you are adding in terms of x. Okay. Now, that is called the integrating constant. Now, differentiate this equation 5 with respect to x. I will get del psi by del x is equal to 2cy plus, again another integration taking place, plus f dash of x. I'll call that equation 6. Now, from 4 and 6, from 4 and 6, 2cy, I will put 4 in equation 6. 2cy is equal to 2cy plus f dash x. So these two will cancel. F dash x is equal to 0. F dash x is equal to 0. Then I will integrate this f of x, one constant of integration, because it was equal to 0. 0 plus 1, that is c1. From this equation 7, I get psi is equal to, what is this? From equation 2cxy plus c1, where c1 is the constant. At the point 2, he has given what is the velocity at 2, 1. From equation 1 and we have velocity is equal to u is equal to 2c into x, that is 2, 4c, and v is equal to 2c into what is y? 1, that is 2c. Therefore, the resultant velocity capital V is equal to root of square plus square, which is 4c square plus square. That is V is equal to root of 20c, so many meter per second. Now, if you get double integration like this, you won't get one final value. You will get c, a numerical also along with the number. But the concept is same. Any doubt in this? Anybody? Any doubt? Yes, Jayant, Ashtesh, Milan.
Sure. No, sir.
Hello?
No, sir.
Yeah, these two problems on velocity potential and stream function I have shared with you in the 4th semester group. If you please see that. Okay. Any doubts?
No, sir.
Okay, Ajay, Akshat. Go on, Raj. Can you hear me?
Yes, sir.
Okay. Please see that I have given a few things. Please see that you read all this, the study material. First one, I have given problems on Laplace and continuity equation. Please see those problems. Then velocity and acceleration. And after that, stream function and velocity potential I have given. Apart from that, I have given you an assignment in Google. Please try to answer the assignment what I have given in Google. Okay? Try to answer what is some 4 questions I have given. Answer the assignment and post it in the Google Classroom. go through the derivation of 3D Cartesian coordinate, problems on velocity acceleration, and problems on stream function and velocity potential. That will complete all the topics, and the second module is completed now. Okay, second module is completed. Okay, now we have covered sufficient syllabus, and in case you have any fluid mechanics textbook at home, please go through whatever topics I have seen and practice so that you will get confidence. Okay, if you do that, then it is going to be very easy for you for the test also and for the. Now, since we have covered sufficient portions, you can confidently take the exam also. Even if they give first test and second test also, we have completed sufficient portions. You won't have any problems because study materials also are given. In case you have any other problem, like any doubts or questions, you are free to contact. Next class, you can discuss whatever is there. But as far as all the topics which are and which are concerned, there is no problem. I think from your side also, can you tell me any doubts or questions? As I think we have completed sufficient portions, and second module is completed. Please finish the assignment, and the last date for assignment is 9th April. Yes, Milan, Jayant, Ashtesh.
Okay, sir.
Okay, sir.
Yeah.
Okay, sir.
Any doubts, anybody? Yeah, if you have any doubts, any other doubts, queries? I hope you have understood
Clear.
everything. Yes, anything else?
None as of now.
Okay, if you have.
No, sir.
Yeah, all your doubts
No,
are clear. Please study whatever material is there. If you have a fluid mechanics textbook at home, please read that also. Whatever topics and chapters I have told you, go through that. Then it will be easy. You can answer in the main exam as well as the test also. So second module is completed. Okay, Tarun? Yeah, can switch off. Okay.
So,
Thank you.
so the assignment is
Yeah.
given on the Google Classroom, right?
Assignment is given in the Google Classroom. In case you find any difficulty in posting it in the Google Classroom, I will connect it once the class college opens.
You had given like 2 questions on the board in class, so that's not needed.
No. Sorry, that was not an assignment actually. That was like a tutorial for you to study. Now, yesterday I have sent you FM, what is that assignment I have sent you, some 4 questions are there. That one manometer, one problem, and 3 other problems I give, and one meta-center problem, derivation of 3D continuity equation, and one more. So 4 questions. Yeah, 4 questions I have given to you as an assignment, and please do that as the assignment. The previous one can be considered as a tutorial, not required. Means you just have to study that one. That's all.
Okay, sir.
Any doubts? Yeah, Tarun, you can stop recording.